500 years ago, artists didn't have laboratories, chemical databases, or modern preservation science. And yet, their paintings are still here. The colors still glow. The details still breathe. Some works look almost untouched by time. So what did Renaissance artists know that we forgot? This is the story of how paint was engineered to last centuries. To understand this, we need to stop thinking like artists and start thinking like chemists.
Behind every moment lies a scientific wonder. I'm Kale, and welcome to SciCurios, where curiosity meets science.
First, the pigments. Renaissance painters didn't rely on synthetic colors. They used minerals, stones, metals, and earth. Ultramarine came from crushed lapis lazuli, one of the most chemically stable blue pigments ever discovered. Red came from cinnabar or iron oxides. Yellows from ochres rich in hydrated iron. These pigments weren't just beautiful, they were molecularly resilient. Their crystal structures resist light damage, moisture, and oxidation. In other words, the colors themselves were already built to survive. But pigment alone is useless without a binder. That brings us to the second secret, oil. Renaissance artists perfected the use of drying oils, especially linseed and walnut oil. These oils don't simply dry, they polymerize. When exposed to oxygen, their molecules cross-link into a flexible but durable film, locking pigment particles in place. This process forms a protective network that slows chemical reactions and shields color from the environment. Too much oil, and the paint yellows or cracks. Too little, and it flakes away. Artists learned the balance through generations of experimentation. And then came the technique that changed everything: layering. Renaissance paintings were not painted in one go. They were constructed layer by layer. A stable ground layer, a monochrome underpainting to control light and shadow, thin, transparent oil glazes on top. Each glaze was only micrometers thick. Light passes through them, bounces off lower layers, and returns to the viewer's eye, creating depth and luminosity without stressing the pigment. This structure also slowed aging. If one layer degraded slightly, the others compensated. Time was no longer the enemy. It became part of the design. But there was one more ingredient most people never talk about: time itself. Renaissance artists worked slowly. Paintings took months, sometimes years. Each layer was allowed to cure properly before the next was added. This prevented internal stress, cracking, and chemical imbalance. Modern paintings often fail because they're rushed. The old masters waited, and chemistry rewarded them. Even their studios helped. Natural light, controlled airflow, moderate humidity, an accidental but effective preservation environment. When scientists analyze these paintings today, using X-ray fluorescence, infrared spectroscopy, and microscopy, they don't find magic. They find material science ahead of its time. Artists who didn't know the word polymer, but understood how oil behaves. Who didn't know atomic structure, but chose pigments that wouldn't break down under light. The Renaissance recipe for immortal paint wasn't written in a book. It was discovered through observation, patience, and failure. And that may be the real lesson. Durability doesn't come from complexity. It comes from understanding materials deeply and respecting how nature works. 500 years later, their colors still speak. Not because art is eternal, but because chemistry, done right, can be.
Science is everywhere if you just know where to look. Thanks for watching SciCurious. Until next time.